Alright, let's try to solve the second problem in your exercises. So, yung exercises muna ang solve natin. Although meron naman na yung mga solved problems in your modules. So, you can also look into those examples. So, second problem, two forces are applied at a point in a body as shown in the figure. Determine the magnitude of the rectangular component of force F1 along the line of action of force F2. So we are to solve for the component of F1 along the line of action of F2. So saan yung line of action ng F2? Sa may line OA. Yan. So ano ulit ang kailangan natin para ma-solve yung component ng force F1 along line of action of F2, which is line OA. So, what do we need? Ano ang kailangan natin? Okay, let's say our notation na lang for the component of F1 along line of action of F2. Sabihin na lang natin na F1 OA. So F1 OA. So which means line of component of F1 along line of action of F2 or along line OA. So is equivalent to F1. F1 should be in its Cartesian vector form, just like our example kanina or sa previous video. Okay, although yung sa previous video, ang example natin is hindi siya force but it's a position vector. So something like a line that has a direction. No. So yung position vector natin. It's a vector, still a vector quantity. But in this case, since given naman yung force natin, meron tayong force. So first is we need to express muna yung force in its Cartesian vector form so that we can perform yung dot product. And then, multiply natin sa unit vector along line OA or sa line of action ng F2. So, that unit vector OA. Okay? So, ito lang kailangan nating malaman. F1 in Cartesian vector form and the unit vector for F2 or along line OA. Ayan. Okay, so first we need to express muna F1 in its Cartesian vector form. Okay, so how do we express F1 in Cartesian vector form? Ano natin i-express yung F1 in Cartesian vector form? So remember, Cartesian vector natin, F1 is equal to F1xi plus F1yj plus F1 zk. Okay. Or you can also use yung position vectors to solve for the coefficients, yung mga magnitudes ng ating components. Okay. So pero since if you plan or you intend to do that, yung ganong strategy na gamitin mo yung position vector or unit vector to solve for the Cartesian vector form of F1, you need to solve for the coordinates of point B, ano? Okay. But it would be easier, I think it would be easier for us to solve for the components of F1 along X, Y, Z axis by simply applying trigonometry. So by trigonometry here. So by inspection sa figure natin, so ito yung line of action ng F1 and it is inclined at 60 degrees from the XY plane. So this is XY plane. So if that is 60 degrees, then this is 30 degrees. So that yung component natin along the z-axis or component, dapat yung red. Yung component natin along the z-axis, if this is fz, then this is also by parallelogram method This is also, sorry, ito pala. So, dapat naman dito. This is Fz, then this is also Fz. F sub z. Yan. Okay? So that F sub z or Fz na lang, is simply equal to, so how do you solve for Fz? So given yung side natin, this is 120 pounds. So 120 pounds yan. And we are solving for the opposite side. So Fz is simply equal to 120 pounds times sine of 60 degrees or cosine of 30 degrees. Okay, so if you're going to use this angle, then Fz becomes the adjacent side, so you have to use the cosine function. Okay, so F sub z now is equal to, I'm sorry, it should be F1 kasi we have two forces pala. So F1z is equal to 103.923 pounds. Okay? So that is F1z. Next, we solve for F1 x and F1y. So nasan yung F1x, F1y natin? So we can, andito yung F1x natin. Ito, yung component natin along x. And nandito naman yung ating component along y. Yan. So this is F1x, F1y. So if there is F1x, parallel siya dito. This is also F1x and this is also F1y kung parallel. Parallel naman sila, no? And same yung kanilang magnitude and direction. Okay? So how do we solve for F1x and F1y? So given naman yung dimensions natin dito, this is 2 feet and this is 1.5 feet. What we need to know is the component of F1 along this axis. Ito, let's say this is, ito yung diagonal ng parallelogram natin, which is the hypotenuse of the triangles that are formed. So this is, let's say this is F prime. So F prime is the component of F1 prime, sorry, of F1 along this axis. So 60 degrees yan. So F1 prime is simply equal to, so this is the adjacent side, 120 pounds times cosine of 60 degrees. So F1 prime is equal to 60 pounds. So if we know F1 prime here, we can simply solve for F1x and F1y. So alam natin yung F1. So we know this side, itong side natin, we similar triangles. Similar triangles. Or we can solve for the slope ng ating diagonal. Slope ng F1 prime. Okay? So itong side na to is 2 feet, itong side na to is 1.5 feet. So and we know this side, no? F1 prime is 60 pounds. What we are solving is F1x and F1y. Itong two sides natin. Tapos given yung hypotenuse natin ng F1 prime. So how do you solve for F1x and how do you solve for F1y in this case? Okay, first we need to solve for the length of the diagonal. So 2 feet ito is 1.5 feet. Solve natin yung length ng diagonal by Pythagorean theorem. Calculator natin. So we have Square root of 2 squared plus 1.5 squared. So that is 2.5 yung length ng diagonal natin. So this is 2.5 feet yung length ng diagonal. Okay? So that if we want to solve for f1x, then by ratio and proportion, or we can use also the slope ng diagonal natin. So, paano yan? So, f1 prime, so f1x is equal to, so since f1x yan, etong side na to which is 1.5 feet all over yung hypotenuse natin na 2.5 feet times f1 prime, that is 60 pounds. Okay. So, f1x is equal to, lang yung f1x natin. £36 pounds. Ganun din sa f1y. So, f1y is equal to, we have 2 feet over 2.5 times 60, and that should be equal to, so, ilan to? 48 pounds. Okay? Ano ba? Check ko lang sa calculator natin. Yes, it's 48 pounds. And check also the sign natin ng mga direction ng ating mga components. F1z is upward, so positive. F1x is pag ganito, so positive siya. F1y is directed to the left, sa may likod, so that should be negative 48 pounds. Okay, so pag alam na natin yung F1x, F1y, F1z, we can simply identify or write the Cartesian vector form of F1. So what is the Cartesian vector form of F1? So F1 is equal to, in its Cartesian vector form, we have 36i, or minus minus 48j plus 103.923k. So this is in pounds. So this would be the Cartesian vector form of F1. So tapos na tayo dito sa una. Next, kunin naman natin yung unit vector along the line of action of F2. Line of action niya is along line OA. Ayan. Line OA. So para malaman natin yung unit vector, we need to identify muna yung coordinates ng point A. So ano yung coordinates ng point A? So x coordinate of point A is, so that is 1.5. Yung point A natin. So 1.5 siya. Yung x coordinate. Y coordinate is 6. And the z coordinate is 4.5. Okay? So, yan na. Okay. So, the unit vector of F2 along OA is equal to the position vector of F2 along OA divided by the distance between itong points natin O and A. So, R. Position vector. Ba't may kwan doon? May IR. Ay bar doon. So, sa module natin, R is in bold. R, yung small letter R na sa denominator is the distance between the points O and A in this particular problem. So, idiretso na lang natin. So, and the unit vector is equal to yung position vector natin. So, head minus tail. head minus tail tayo. So we have 1.5 minus 0, I. Plus 6 minus 0, J. Plus 4.5 minus 0, K. That's our position vector. Divided by distance natin. So, copyan lang natin yung numerator. Okay. So, distance formula, square root of the quantity. So, we have 1.5 minus 0 squared plus 6 minus 0 squared plus 4.5 minus 0 squared. So, our unit vector is equal to, so simplify na lang natin ito. So, we have 1.5i plus 6j plus 4.5k. Okay, divided by, so what is the value for this? That is 7.649. Okay, 7.649 feet. So, i-divide natin each term sa denominator. So, 1.5 divided by 7.649, that is 0.196i. Plus, so 6 divided by 7.649, that is 0.784j. Plus 4.5 divided by 7.649 is 0.588. Okay. So, okay na. Meron na tayong F1 in terms of its Cartesian vector form. And meron na rin tayong unit vector along the line of action of F2, line OA. So, pwede na tayong mag-perform ng dot product. Okay, so yung component of F1 along F2 is equal to, medyo kailangan natin na mas maraming space. Ayan. So, F1 OA along OA is equal to, so dot product. So, we have 36i, 48j plus 103.923k pounds dot yung ating unit vector along line OA. Ayan. Okay. So, yun na yung ating operation, dot product. So, again, combine yung mga magkakaparehas. Combine lang natin yung magkakaparehas. So, that would reduce to 7.056i minus 37.632j plus 61.107k. So, yan na yung result nito. Okay? This is in, all the quantities are in pounds. Okay. So, F1OA is equal to, dito ba sa camera? So, 7.056 minus 37.632 plus 61.107. Okay, so, going back, baka nakalimutan nyo na ulit yung principle natin in adding or performing dot product. Okay. So, the expansion of a dot product in terms of the scalar components of the vectors is equal to the sum of the products, okay, sum of the products of the respective scalar components. So, sum of the products of the respective scalar components. Ayan. Kaya, ang product na yan, no, na-multiply na natin yung mga kakaparehas, and then i-add natin yung mga scalar components. Okay? That's how we perform dot product. So, F1OA then is equal to, so, add lang natin itong mga values na ito. We have 30.531 pounds. So, yan na yung component ng F1 along the line of action of F2. Okay. So, I hope na malinaw ang lahat-lahat. Okay, so we'll have another example sa isang separate na video.